Now that we looked at the basic sine and cosine graphs, we're going to take a look at what effect changing the amplitude and frequency has on a graph. So here is our sine curve. It's our basic y equals sine of x curve. And if we take a look here, the number in front of sine, that is our amplitude. And if we change it, so if we move it, we start to see something happening to the graph. Okay. So basically, as our a value increases, the height of the graph increases. So the max and the min changes. So let's take a look at three graphs. Y equals sine of x, y equals 2 sine of x, and y equals a half sine of x. I'm going to graph both of them. So our plain y equals sine of x graph starts at the midline, goes up to 1, back to the midline, down to -1, and back to the midline. And then we just do a nice curve as best as you can. That was pretty terrible. Okay, let's take a look at y equals 2 sine of x. Again, it starts at the midline, so same point, but this time it goes up to 2, back to the midline, to -2, back to the midline. And finally, y equals a half sine of x. Well, it starts at the midline, but this time the maximum is a half, and the minimum is -1/2. So we could see that it doesn't go as high. All right, here's better looking graphs. Okay. So now we can answer, what effect does amplitude have on the graph? So the amplitude changes the height of the graph. So it basically is affecting the max and the min. Now changing the frequency does something else entirely. So let's take a look. We'll go back to Desmos. And let's put the amplitude back at 1. Okay, so we have our basic y equals 1 sine of x. And let's take a look. So here I'm increasing the frequency. So now the frequency is up to 7, 8, and keep going up to 10. Basically what the frequency does is it shows you how many cycles of sine there are in a 2 pi interval. So this is 10, so there are 10 cycles. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, back to 2 pi. If I make it our b value 2, well then there's only 2 cycles of sine, 1 and 2. Okay. So once again, let's graph 3 sine curves. We'll start with our basic sine of x curve. And this is the one we're most familiar with. Now y equals sine 2x means we see 2 cycles of sine in a 2 pi interval. So we have to see there's 1, and there's going to be 1 more. So we have to fit 2 of them in this 2 pi interval. So it's almost like we're going to have to graph double the points. And then we can go ahead and connect. There's our first curve. And there's our second curve. And finally, sine of a half x, well, we're only going to see a half of a sine curve. So we're just seeing this first piece, which means we're going to have to graph half of the points of our original sine curve. There's our first one. Now we're going to skip. Here's our second point. We're going to skip. And there's our last point. It's just going to be this piece here. And again, here are some neater graphs. Okay, what effect does frequency have on the graph? Okay. So frequency tells you how many cycles there are in a 2 pi interval. Okay, so frequency tells you how many cycles there are in a 2 pi interval. In this example, we're given a graph and an equation. So the equation is y equals 4 cosine of a half x. We're asked to find the amplitude, frequency, and the period. We can do this two ways. We could either use the equation or we can use the graph. If we use the equation, the amplitude, well, that's the number right here, it's the absolute value of that number, so the amplitude is 4. If we use the graph, we look to see the distance from the midline to our highest point, or from the distance, or from the midline to the lowest point. So it's 4. Or if we went this way to the lowest point, it would be 4. Frequency is how many cycles we see of sine or cosine in a 2 pi interval. So here's 0, here's 2 pi. Well, this is a cosine curve, so a full cosine curve should look like this. Now, we're not really seeing that, we're only seeing half of it. So our frequency is a half. We could do it from the equation as well. It's the b value, number right there. And finally, period. Period tells you how long it takes one full cycle to end. So here's one full cycle. Well, we can use our formula that we learned the other day, which is 2 pi divided by frequency, or 2 pi divided by a half. And 2 pi divided by a half is 4 pi. But if we look at it graphically, half of the cycle goes to 2 pi. Well, then it would make sense that the other half would have to end at 4 pi, so it would end over there. And again, period tells you how long it takes for one full cycle to end. So now that you have a good grasp of the effects of amplitude and frequency, next lesson we are going to start graphing some of these curves.